There's like 1 or 2 editions. But the talk name is The Timeless Way of Building, which references a Christopher Alexander book. Most people have heard of his second book in the 3-book series called A Pattern Language. But The Timeless Way of Building is actually the book that precedes it and sets it all up. So real quick, we'll go through basic background for me. For those who don't know, I have my master's in architecture, self-taught programming, design, outside of that stuff. Done everything from print to web. Started on web in like 95, 96. Ran an agency, still kind of do on the side, and do a lot of high-end UX stuff, but also do programming and other. So we did a short film. We do some 3D animation stuff once in a while. About a year and a half, I did run a company with Amy Hoy called Hyphenated People. And we did a lot of UX stuff for Bear Stearns before they failed, and Gary Vaynerchuk and people like that. I do play the rock and roll music. That's me at the Verizon Center with the arrow. This is us opening for Coldplay. But this is the biggest show we've ever done, and we have done nothing like it. We went like and played a shitty bar the next week. So this is our one claim to fame that I'll tell my kids. Yeah, I played at a big rock show once. I was in InfoEther, and we got acquired by Living Social. And that's
was one of those people a cardboard cutout?
No, it looks like it. The key light. There's a Doug Saunders is the photographer that does this, and he does a lot of rock photography and stuff like 3 Doors Down and stuff like that. But he did a key light flashing from behind too, so it makes Dave Crane on the right there look like a cardboard. So we got acquired in March of 2011, and about 60% of the team is still there from the last time I was here, I was talking about this guy, the Rails View book. If you have any questions about that too, we can talk about that at the end. But today we're going to go and talk about 4 things and kind of jump through this. And we'll be jumping back and forth, but this is kind of the flow that we're going to go through. So we're going to talk first about what patterns are, and then we're going to talk about architecture and where patterns come from. So they're derivative out of the architecture world. Then we're also going to look at anti-patterns and how we can apply that to our code and how we work with the Rails stack. And then we're going to go and get deep on theory at the very end. So patterns. Basically, how many of you guys are familiar with this book? The Gang of 4 book is what it's called. This is something that was written mainly for people doing static type languages like C and Java. And it's really what kind of introduced a lot of programmers to the concept of patterns. And they define patterns as such. A design pattern, it systematically names, motivates, and explains general designs, and they address recurring design problems. It describes the problem, the solution, when to apply it, the consequences, and we've got hints and examples. And it's a general arrangement, so it's not a specific thing. It's very general that can be applied broadly. So it's not talking about when you're writing a medical thing. No, there's none of those conditions. So again, design pattern's got a pattern name, and this is the handle. Like, so we can talk about, if I'm going to talk to you about test-driven development, that's something that you can immediately attach to and say, oh, test-driven development, I know what you're talking about. There's a world around this. So the problem, when do we apply it? What's the right context that we want to use this in? The solution. So what elements do we kind of pull together? And again, it's very abstract. And the consequences. There's always, any choice has trade-offs, especially in development. So what's the benefits, what's the detractions of going down this road? What does it set us up for, positive and negative ones? So patterns, they help identify the less obvious abstractions, but things that aren't necessarily in nature, but they're going to be things that we end up building. It's not like a domain model is really, when we start talking about nature, we really go after the domain model. But here's an example from the Gang of 4 book. So this is the iterator pattern. And it's one of those things that we don't think much about in our daily existence, because when we want to iterate over something, we just type that. So if you think about, most of the problems in the Gang of 4 book are things that Matts and guys like that have solved in the Ruby language and kind of gotten that crap out of your way. So when a lot of the patterns for us, we don't think about patterns in the same way. So, what patterns consist of, but where did they come from? And it's not, the old tartan or the kilt, and it's something from architecture. So this is a Corinthian capital from classical design. And so classical has a very broad language of architecture, and it evolved over hundreds of years. if not thousands, depending on how far back into antiquity you want to go. A guy named Christopher Alexander, who's an architect and theorist and writes lots of various books on. He's also into agriculture and stuff. But he wrote this 3-book series. And this is kind of the 70s hippie thing. And so this was timeless way of building, pattern language, and then the pattern language actually gets applied in a book called The Oregon Experiment, where they actually go to Oregon and build a college campus. And this was his quest. How do you distribute the responsibility through all levels of a large hierarchy and still have consistency and harmony and don't have just this crazy cluster that looks like somebody went in and just paper mache shack here and wood shack here. And so the large hierarchy they were working with was a college. So you have professors, you have administrators, you have students. How do you involve them in the design of the space they're going to use, yet not get hodgepodge and horrible design? Because from an architecture perspective, if I'm going to work with a client, I don't know everything about that client. Part of the job is to try and just absorb as much as you can, but you can't possibly become a physicist as an architect. It's just, there's not enough time to go back and do all the stuff that they do and really understand it. So you have to get close, but how can I have them involved in the process that improves that? So back to the book. So we're trying to solve that central problem. But if you look at the patterns that he starts defining, contrast, positive space, these are the high-level patterns. So when you start thinking about patterns, we need to start thinking that principles are also patterns. So for example, in our world, this is a pattern. Don't repeat yourself. You ain't gonna need it, that's a pattern. Single responsibility principle, open-close principle. You might know where I'm going with this. So patterns contain patterns. Patterns all the way down. If you want to think about it that way. So a lot of times we'll say, oh, that's a principle, or that's an implementation, or that, and arguably every one of these things is a pattern. So in architecture, these things kind of evolved, because architecture wasn't formalized until the 18th, 19th century. The École des Beaux-Arts in Paris was the first architecture school, and it basically was teaching neoclassical design. But pattern books started coming out in the 18th century, where famous builders and architects, the Adams brothers in this particular case, would design. They did a bunch of theoretical and actually built designs, and so it was kind of their portfolio brag book. But they would ship this, this was like the height of London, and all this kind of stuff being built. And so people in the States would get these, and they'd be like, well, I want to look like that. So they'd get Georgian or whatever kind of pattern books, and they'd try and copy them here. Now we had different building materials, different kind of building technologies in the States, or the colonies at the time. But you have a lot of these details. And so somebody here could give this to their master builder, because there was no going and getting code review and getting a stamp. It was, hey, can you build this? Yeah, we can build that. And some examples here, this is from Robert Morris's Select Architecture. So this is 1750, and this is plate 3. Don't know what it is. It probably wasn't actually ever built in from his perspective. But if you look at Battersea, this was begun 18 years after that book was published, and this is in Petersburg. So this is not a copy of this, but you can start to see some replication. I've got, towers at the end. I've got something adjoining it. I've got a central space that is double height, and that applies here. So this is an implementation of a pattern, quote unquote, a very specific pattern. But you also go back to Andrea Palladio. So this is 16th century, 1500s. He wrote the 4 books on architecture, which was a lot of the codification Jefferson used, and a lot of the neoclassical guys. And he also built a lot of structures. So this is Villa Cornara. And from here, this is the first draft of Monticello. So you can again see very much where Jefferson was like, I like that, but I don't need 6 columns, I just want 4. And I don't really need it to be that wide, so I'm going to cut off this big secondary thing around it and just use the central portico, et cetera, et cetera. But then Jefferson went to Paris and he saw this building. So this is actually 3 or 4 stories tall, but it doesn't look. And so this is now the elevation you know. So we went from that to that, but this was all working in a language, and he's sitting there and saying, oh, I'm going to pull this element from here and this element from here. And the thing about Monticello that's surprising is that is 11,000 square feet. It doesn't look it from the outside, but it's 3 stories tall with a basement. It's a huge house, but it seems small. But it's it fits the landscape, but it's not. It doesn't seem opulent. Anyway, so they're working within the language of classical architecture, so you can start pulling these pieces and swapping things around. And as we get back to that, that is what the pattern language is kind of being extracted from. Some examples of other patterns that you might not think about. So this is a pattern called light from 2 sides. Right now in this room we have light from, well, we arguably have light from 2 sides, but we really have light from 1 side behind us. So this space, this is the Wren building at William & Mary. Compared to this is light from 1 side. Much different feel, right? It's not a bad character, it's just a different character. Now, what's this? Exactly. But there's volumetric space here, and now this is light from above, and it feels completely different than the previous 2 examples. So this is just a very simple thing that could be applied in anywhere. It could be applied inside a violin, but most people don't ever see it. Thanks to a pinhole camera, we do. But if you think about going into an atrium, where there's no light from the windows, but just light from above, these evoke feelings. Another thing that Alexander uses is Amish barns. So the Amish just construct. They don't get together and say, "Oh, we're gonna draw up these plans." They're like, "Yeah, you want a barn? Great. We can do a barn on Saturday. What do you need?" "Well, I got 4 cows and I got some chickens and I want to have some goats." So okay, they can just sit there and talk about it. You need another stall. We just add a bay, and they have this kind of inherent language of how they build buildings. And they don't have to sit there and go down and let me get an architect, let me get an engineer to stamp it. They may now just have to get it stamped, but the way they've always worked is they just get together and build it. So you'll go through central Pennsylvania, you'll see thousands of barns, and they're all a little bit different. But you can all say, that's an Amish barn. There's a character about it. And this kind of comes down to what you've heard this a lot. We've been talking about craftsmanship in software development lately. And so you get craftsmen. We're software engineers. We're software architects. So what this really comes down to is we all just want to be builders. Let's be honest. It's not a wrong analogy. Glenn Vanderberg had pulled this quote: "Engineers frequently have to make decisions of great practical consequence in the face of incomplete and uncertain knowledge." How many of you does that sound like your daily workflow?
That was a couple hours ago.
Yeah. And patterns help us do that. Yeah, they help us look at the best practices to solve the problem. However, too many people think that design patterns are just a library of copy-paste code or designs, and this drives me nuts. This is patterntab.com. These are not effing patterns. They're designs. They're implementations of patterns, or instances of a class, if you want to get programmatic about it. So I beg that people stop confusing the piss out of the newbies this way, and stop calling these things patterns. Call them, you can call it a design library or a showcase or show and tell, and you can talk about the pattern that's referenced, but this is not a pattern in and of itself. It's an example of an implementation of the pattern. And Brian Hogan, the guy who edited my book, said this: design patterns are suggested approaches seen in the wild. So, you actually come out and find it. So what are we striving towards, right? And I mentioned it before, it's the quality of space that has no name. This is what Christopher Alexander calls it. And so how do we see that happening in code is what I want you all to think about as we go through some of this. I'm going to jump back to architecture here. This is Gibellina, Italy, or was Gibellina, Italy, I should say, at top. It was destroyed in a quake in 1968. And a new town was built 20 kilometers away, and they moved the whole population there. An artist went back in and put concrete down that's about yay tall, so you can still walk the streets of old Gibellina. But there's no buildings. It's just these concrete forms on the hillside. But this is, you can see how tight those streets are and how small and how integrated into the landscape this town was. The new city they brought all these prominent architects and artists in Italy together, and they did it piecemeal, but there's no shared language. It's like everybody signing their name with a different signature on a big card and throwing it down on the Italian landscape. There's very little vernacular architecture. It could be anywhere. It doesn't feel like Italy to me when we were there. And it feels like a ghost town. Middle of the day, there's nobody on the street. And if you go into a small Italian village somewhere, the shopkeepers are sitting in front of their shops in the middle of the day. Here it's so hot, there's no shade, there's nothing, it's just these open plazas. Everybody's inside, everybody's hiding. It feels very much like something out in New Mexico or Texas would feel. So this is what I call an anti-pattern. It's not, they're basically smells, is a good way to think about it. They're the most obvious examples of a non-fluent developer or an architect working in the code or the built environment. It's building a house on a crappy foundation. It's unlike architecture, we have the benefit though that we can fix the crappy foundation pretty easily. We don't have to tear the entire structure down, at least in most cases. So in the next couple slides here, the little red X in the upper right-hand corner is bad, and the little green check mark is good. So that's just a little
way to close your presentation.
Yes, we're done now. So, like I said, here it's this is a ghost town. It was done horribly. It doesn't really work. So this is an architectural pattern. Another one. So you can think about big ball of mud is a programming term you'll hear around, or shantytown. It came from the big ball of mud paper. But there's too many tools. Everyone's working in their own direction. No investment in infrastructure. It's kind of a shantytown. From an architectural perspective, it's a very, very correlated thing. This is one of my favorite ones. I asked before I did the talk, like about a month before when I was working on this, what's your worst things you've ever seen pattern-wise? And Pete Jackson from Intridia wrote back, discovering that a top consulting firm practiced TDD for active record migrations. There are a few cases where that might make sense, but I mean, every day in and out, it's kind of overkill. If you had something where it was like the entire system's going to be rewritten and we have to migrate all this and nothing can break, okay, maybe some tests are in order. But add your timestamps. Do I need to test for that?
Is that like should have column? Or?
Yeah, I guess. I don't know. I mean, but it's one of those things like there are things in migrations that should be tested, but just testing everything in migrations is kind of ludicrous, especially from a development perspective, because you're going to run that locally. If you're doing major changes to the database, fine, okay. But this is stupidity. This is following a pattern blindly. Walking the tree, fat models. It's just just like anything, maybe personal weight gain or not exercising. These are things that we get to very slowly as we build up an app. A method here, a method there, and suddenly it's you've got this long selector that one thing gets changed, the whole thing breaks. So, this is also seen as inheritance everywhere. And the way around this is to start talking about composition and delegate. So instead of a long tree where one change breaks, we're going to look at something extracted. This lives in parallel to our class and acts as an SRP for those functions, single responsibility principle. So this is bad. Because very quickly, one little change anywhere along there can break everything. So instead, this is something where you start extracting these things out to methods. Now, I'm sure that in 10 years, somebody will say this is awful and horrible code, and that's what happens. We develop and we move forward and we change. But right now, this is kind of the log demeter class level delegate method is the way to beat the walking the tree. Because the first time I walked the tree, it was like, this is so powerful. I don't have to do anything. It's unlike PHP where everything is declared. I can just start exploring my database, and then things break. So yeah, I think that got out of line. That should have been fat controllers, I think. Sorry, one second. Oh, okay, this is fat models. I think I had a slide. I think the fat model slide earlier was out of order. So if you can go through the model and group the things into logical blocks, right? Those things are ripe for refactoring. So that's where we can start looking at modules. In Rails 4, we can talk about concerns. Plugins are on the way out, but some people still like to use them, and some people are like, we're still supporting some Rails 2.3 apps. We're trying to get them to Rails 3, but you can keep using plugins if it's in that wheelhouse. Gems, obviously, at a point, if this is something you're going to use all over the place, a gem is a great way to extract that to a library, and the app within the app, the engine. So Wild, the gem that I showed some of you guys last time I was here, is an actual Rails engine. The documentation runs from the engine, and then the gem itself has the library. So that's how we share that across 20, 30 some odd applications that all use that style guide.
Was that the administrative style guide?
Yeah.
Okay.
Yeah, the internal tools. So anything where you can say, okay, can I group these items into one, these methods into one? Yeah, I can pull that out and make that a module, make that either a concern or something like that. And then if I have these things that are shared, that's when you start looking at other ways to do it. Callbacks, these are really powerful, but transactionals. It's if your app doesn't seem to fit the life cycle for Active Record and you're trying to work in Rails, you're either doing something really complex and custom, or you're probably fighting Rails every step of the way. So can you refactor them to transactional elements? And can you attach those behaviors not in the controller through the before save, after create kind of things? These are a great stopping point, but like they're great in and of themselves because you can refactor from crap to them, but then they in and of themselves become problematic too. So it's kind of stepping stones. And I don't have a good solution to go past these right now, but they can become a mess if you, especially in really large apps like some of our pipeline apps, because you start having conflicting things that happen because you have two different after create commands and somebody didn't look. But Rails is a series of very large libraries, and a lot of people don't read the libraries. So learn the power that exists in the stack. We see this a lot with the Rails.js and those kind of review things is where I normally see these problems. But there's a lot of stuff that people will include a gem for it that's already included in Rails itself, and they'll add another. And it's another liability. It's another thing you have to keep up to date. So dig into the reading the source, because there's gold in them here. Them there hills. But, and some of this stuff is like complex finders. I when I first started reading through Rails Antipatterns, the book, which is a pretty good book to kind of start learning some of these smells if you haven't. This is one of their examples, and it's just. You don't think about it, but you can stack scopes, and this becomes really powerful. And this, unlike walking the tree, you're doing multiple methods as opposed to walking through multiple models. So this is not as like a bad thing, but this is really powerful. Now, if I want to change what running means, I can change it globally. I don't have to worry about it. It's kind of the nice thing about using CSS for a lot of those things. Generate methods. Create lots and lots of crap code. They're really, really fun, and they're really easy to use, and you get your files made, but they always end up with something. So it's always better to go for something with, are you using all the tests? Are you using all the migrations when you generate a model? If you're not, just create the files by hand.
There should be a T-shirt that says, "This shop has gone 200 some days without
without a generator."
Without a generator or something.
Yeah, and sometimes you can even make your own generators if you know you're going to do something 100 different times the same way. But a lot of time, this is not as egregious as, say, our Rails G scaffold, but you still end up with a lot of cruft, especially in big apps, especially if a new person doesn't know, I got 30 files created, okay, commit, they're all empty. This is one that I see a lot of. It's the early extraction and making too much complexity when it's not needed. So DSL, all the things. You do not necessarily need a DSL or a custom gem or something. It's one of those things. It's like when you feel the pain, that's when you jump in and say, okay, here's how we refactor out the pain. But people that start off and say, I haven't even written a line of code and we're going to make a DSL. Okay.
What's the DSL?
Dynamic domain specific language. There we go.
So like
a migration is a DSL. A Rails migration.
DSL, RSpec is a DSL.
So they're in. It's written in Ruby, but it's written about the domain. So it's you have a whole bunch of methods that come with it. Yeah. How many of you guys did PHP before Rails? You don't have to be embarrassed about it. Okay. PHP just colludes everything in the view. So the view and the file, and it's just all one big thing. Now there are some people that can write object-oriented PHP, but it's still, to me, is confusing as hell. But divitis, PHP-itis, bad Java practices that people bring over. One that I think just got a whole lot of flack back and forth from Rain Hendricks was some guy talking about something with integers and some crazy thing, and it was like basically the guy took Java-isms and wrote them in Ruby and wrote them poorly, and was all excited to share it. And Rain Hendricks just was like, he just kind of like went over it with an A1010 killer. It was not a pretty sight. But this is the kind of stuff. we want to use the view conventions, render partial, render collection, the content for blocks, instead of assigning that content to an instance variable. These are the kind of things that are, these are these anti-patterns that keep popping up. One that we've just done a lot with, I don't know if any of you guys read Dave Copeland's blog, Nail 5 Driving or Nail Driving 5, but he did this thing about typographic refactoring, where you don't change anything, you just make the code more legible, and it creates a lot more lines. But we actually did a whole pass on the view code of this, and people are like, why are you doing that? It's like, because I can now read what it does. Instead of having these operators that are 200 characters long, and you can scroll left and right, everything's under 80 characters, everything fits, it's very clear.
And what type of code?
Any code.
Any code?
View code, Ruby, anything. He wrote it, the blog post is here at the bottom, and he wrote that about, he shows a Ruby example and a couple other languages as well. But he's at Stitch Fix now. He was at Living Social. Sorry, you want to get that URL down? You got it? Okay. Model view controller. This is a pattern we all know. We use it daily. It came from Smalltalk, though. So it decouples the views, the model logic, the controller actions. It's a pattern in and of itself, and it contains many other patterns. So MVC contains, in the Gang of 4 book, it contains observer, composite, strategy, a couple others. And so you think about controllers have a class hierarchy, all these things are patterns that make up the MVC pattern. Some view refactoring that you guys have seen before. This is, if-else constructs. We do all this all the time. So presenters and decorators and all those are patterns. They're very broad. You can do a lot of different things with them, but this is the one that I did to refactor that if-else into a single, what looks like a fake database column, location info. But instead of having to have the if-else in the construct, the if-else is called in code where it can be tested. Speaking of untested code, action view test case. You can test your helper methods. It should be tested. Complex view logic. Presenters. You can test them. If you're not testing at all, well, God have mercy on your soul. Fat controllers, like fat models. We've got too much weight in the controller. This really comes down to the looking at opportunities to extract methods to the model, reduce repetition, and it's not saying that we can only have 7. You can only have the CRUD actions in there, but looking for ways to make the methods more usable. I've seen a lot of controllers where you get 20, 30 line methods that just become really hard to follow, and that's kind of stuff that should be extracted. So when I'm looking at the controller quickly, I know it's going to call this thing. Okay, now I can drill down into that method that's over here in lib, or in the model, or something like that. Test-driven development, this is a pattern, and we'll talk about this actually at the very end, tying things back up. But most programmers would just think of it as a best practice or maybe something like that, but test-driven development is a pattern to solve how you code. So if you really want to dig into this stuff, there's 2 great books on this, Rails Antipatterns and Design Patterns in Ruby. Rails Antipatterns is Rails 3-ish, so if you're looking at Rails 4, some of it might be dated. But it's got a whole lot of examples and pain. So I would recommend actually sitting down with your junior developers when they're first going through refactoring, say, read this book and then identify everything in the code you just wrote that you should fix. Because it's great, because a lot of times they just don't, they're like, it works. Great, that's step 1. Now how do we make it better? And I don't know, I have a lot of crap code that I've written, and I think everybody goes back and looks at the code they wrote a year ago and says, God, what was I thinking? This is awful. But that's what we're constantly growing. So how do we get those new people to really understand that this is a process, not a destination? So the kernel of the way. What should we do? This bears repeating. If we will advance. There we go. Design patterns are suggested approaches seen in the wild. Likewise, Evan Lang, fat model or skinny controller. These are all just recipes. So think, do what works best in the context that you're working in. Jeff Atwood has written a whole bunch on patterns. Most of this actually was before Rails was even invented, 2005-ish. He went on a tirade for about 2 months about patterns. They should be avoided unless they're absolutely necessary. And that's the first thing a beginner needs to be taught. And right now, beginners are like, hey, read this book on patterns. Okay, So immediately the beginner is going to say, you could apply, but that's not what we're looking for. That's great that you're thinking that way, that's cool, but stop thinking just about patterns. Thinking about code is what we should be doing. Russ Olson says it nice, that you can't say that you're correctly applying a design pattern unless you're confronting the problem. So a lot of times you'll see patterns misapplied and applied incorrectly, and that doesn't help anybody. And here's another Atwood quote. I mean, there were probably, I don't know, 20 to 30 pages if you printed it out of him just ranting. And it's great if you want to go and just read about pattern problems and see that it's a perpetual problem of learning. So mediocre developers never ask why. They go for the first solution to keep moving. And you know what? When you have a 300 ticket backlog, sure, I think that's probably how most of us would probably approach it. But remember, it's not about using patterns. It's about speaking a language. And that's not saying Ruby. I'm talking about the language of software development. So if you think about a chess master, they are working more on intuition than they're actually thinking about every move in a binary tree. Big Blue was written to work in a binary tree and run every process and see what possible outcome could be. But the chess guy, he's like, okay, well, this is how the board's kind of feeling, and this is the move that I think I should make. But going back into theory, like we said, we're looking for the quality of space that has no name. So the quality of code that has no name. So the character has nothing to do with language in the end. Really, it's about the process is coming out of something that's native to us. It means something inherent. It's almost coming out of the soul if you want to get into the really kind of deep part of it. It's something that reminds you that you already know this in the back of your brain. And it's not saying, oh, I'm going to go look up this thing. It's like, this feels right. This is the thing that I should be working on. So this is one of the best pieces of the quote that I think applies really, really strongly to programming. So to make a building egoless, the builder must let go of all his willful images and start with a void. How do we do that in software? And the argument that Evan Light came up to me with is test-driven development. This is the best argument for test-driven development in writing ever. And it's, the quote continues, that you're not going to do it when you fear nothing can happen. You can let go of like, I'm going to build software in this way because this is how I know it. So as opposed to saying, well, what does this really want to be? What does this really need to do? So it needs to come out of the language. Now, we don't start speaking languages like when you take Spanish or whatever in high school. You have to think about it. You don't start just speaking in tongues. But that's the same issue like with software programming. You don't just like sit down and just type and it magically comes out. But you'll see some guys, once they get really good, like I've sat and watched Rich Kilmer code, and it feels like he is just typing stream of consciousness. And he'll jump up and down and jump around, but it's just like flowing so fast his hands are having a hard time keeping up. And that's that fluency. When you speak English, you're not sitting there saying, oh, I'm going to use the present perfect. But that's what a lot of programmers end up doing right now. So, when you first start relaxing, you say, oh crap, I don't know how to say this. And when you're speaking Spanish, you're like, what's the word? Or if you're taking multiple languages, you start mixing Italian and Spanish, which I do all the time. So a place or a piece of code can have all these good patterns, and it can be awful. It can be horrible. It can feel dead. Like a great example is if you go to any of these kind of like new shopping malls that are meant to look like the street, but they're all designed by the same guy, and so it feels a little Disney. It has the good patterns, but it doesn't feel right. Something's off. Something in the back of your mind is like, no, this is fake. But you walk up and down Granby Street, and this is 400 years of development that has built this. And there's good and bad, and there's stuff that will constantly change. So you can find those places that can still be alive. So alcove is a pattern that's talked about a lot. Alcove is an entry area. Simple enough. It's when you start working in architecture, I'm going to use an alcove, and I'm going to use light from two sides. And same way that, I'm going to use operator, or I'm going to use iterator. If you're working in static languages, you're going to think that way the first time you start doing it. But you start to get to the point where you just draw an alcove in this area as you're drawing the overall design because it's just there, and it's the subconscious animal instinct to do. That's what it should be, simply because it's appropriate. So what I really encourage everyone to do is, instead of reading a pattern language, which is a nice library of architectural patterns, is to actually read The Timeless Way of Building. which talks about where patterns come from in history, how you get there, and how the thought process around patterns exists and evolves. And just as a native speaker, once you know the language, the patterns fade away and they just become part of how you speak. And so the goal is that we want to be able to do that with software. Now, we change languages and things like that, but the concepts of software development don't change dramatically. We're still working in a lot of the same paradigms that were invented in the 60s through the 80s. Now, some of those, we've had new things come along, but basic stuff still exists. So these are the 3 books. If you're really bold, go read all 3. If you, they are heavy theory books, so be prepared for that. The one benefit is that he writes and he breaks it into italicized and non-italicized parts. You can read just the italics and get the gist of the book. And then if you really want to dig in, you can go back. And he even says that up front. He's like, if you only have a couple hours, just read the italic parts. So if you're like, I don't have 2 weeks to dig through this book. I mean, it's an inch thick, but it's dense. I mean, it's not something like a fiction book where you can sit there on the beach and be like, whoo, done. You really got to think about some of this stuff. So, I think that as you look at this stuff, it's the why. It's a timeless way of building architecture, but there needs to be a timeless way of building software. Now, maybe we're too young. Maybe we don't. Maybe the architecture has been around for a long time. Software is not. So maybe we're still at the point where it's the Wild West or Wild Grease or whatever. But I think that you'll find a lot of stuff that applies to how we should build software as well. And so I encourage you to kind of dig through that and look at architecture and look at those patterns and think about everything as a pattern, patterns all the way down, and then try and make those parts of that world part of your subconscious language. So when you're working, it just becomes second nature.